Hi everyone, welcome to our exciting journey into Python programming series. This is second episode. In this episode, you will understand how data types and operators works. Without wasting time, let's go through our video. In Python, the first basic thing you should be aware of is every value you store in a variable belongs to a certain data type. And these data types define what kind of data a variable holds and what kind of operations can be performed on them. As you all know, Python being a dynamically typed language, it automatically assigns data types based on the value you store in a variable. These are the various categories of Python data types. Let's explore each one in detail. First, let's understand numeric types. Numeric types represent numbers and include integer, float, and complex. Integer represents whole numbers, either positive or negative, without a decimal point. It is mainly used in indexing and counting. This is an example how we assign an integer. Moving to float. Float represent numbers with a decimal point. It is used in mathematical calculations and measurements. This is an example how we assign a float data type. Coming to complex numbers. These represent the numbers with a real part and an imaginary part. These are used in scientific calculations and signal processing. This is how we assign a complex number to a variable. Moving on to the next category, sequence. Sequence types are used to store collection of items. The main sequence types are strings, list, and tuple. A string is essentially a sequence of characters enclosed in single or double quotes. This means you can perform various sequence operations on strings such as indexing, slicing, concatenation, and iterating through each characters. This is an example on how we can store a string in a variable and how to print it. Next up is list. A list is a ordered and immutable collection of items. Here, mutable means you can change their elements and you can perform different operations like append, remove, and sort. You create a list by placing all the elements inside the square brackets and separated them by comma. As you can see in this example, we created a list named fruits which contains apple, banana, and cherry, which are separated by comma and enclosed by square brackets. It is very important to learn about list. It is because due to its flexibility and ease of use. Advancing to tuples. Tuples are ordered and immutable, unlike lists, means once they are created, they cannot be modified. Tuples are defined by enclosing the elements in parentheses. As you can see in this example, coordinates, the elements are separated by commas and enclosed in parentheses. As I have already told, tuples are immutable and cannot be changed to add or remove items after the tuple is created. This immutability makes tuples useful for storing data that cannot be modified. We can access these elements in tuples using indexing similar to a list. Tuples also support concatenation and slicing. Next, we will look at Boolean. Boolean data type in Python can have one of these two values. It may be either true or false. These values are used to represent the truth value of an expression. If we consider the following example, print 5 greater than 3, it gives true, and the other 2 is equals to 4, which is false. Boolean values are often the result of these comparison operators and logical operators, that is and, or, not. These are logical operators. These are commonly used in control statements like if, while, and for to determine the flow of the program. Next, we will cover sets. A set in Python is an unordered collection of unique items. A set is defined by enclosing the elements in a curly braces. They are mutable, meaning you can add or remove elements from the set. Here, unique items means a set do not allow duplicate values. If you try to add duplicate also, it will be ignored. As it is unordered, you cannot access elements using index or a key. Sets support various mathematical operations like union, intersection, and difference. Sets are particularly useful for membership testing and eliminating duplicate values or entries. They provide a highly optimized method for checking whether a specific element is contained in the set or not. Moving forward, let's take a look at dictionaries. A dictionary in Python is a collection of key value pairs. Each key is unique and it maps to a value. For example, in this, name is the key and John is a value. Dictionaries are defined using curly braces with keys and values separated by a colon. You can access the values in a dictionary by referring to their keys. Dictionaries are mutable, so you can add, remove, update, delete either key or values. Dictionaries are incredibly efficient for storing and managing data in key value pairs and for fast lookups. Next, we will explore an interesting concept called type conversion. Type conversion is the process of converting one data type to another data type. There are two main types of conversion: implicit conversion, explicit conversion. Implicit conversion is a automatic type conversion done by Python, whereas in explicit conversion we manually convert the data type using functions. Implicit conversion is done by interpreter to prevent data loss. If we consider the following example, if we want to perform a sum in between an integer and float number, consider this int as 20 and this float as 5.6. Then Python interpreter will automatically convert the int to a float and perform the sum. As we can see, after running the program, we get the result 25.6, which is a float. Explicit conversion is also known as typecasting. This is useful when you need to ensure that the value of a specific type. Common functions used for explicit typecasting include int, float, string, and boolean. In this example, we take a look at int function. As you can see in this example, we take a num string 100 and by using int function we convert it to a integer. As we can see in the result, it is not represented in single or double quote. This means that it successfully converted to integer. Operators are symbols that are fundamental to perform various operations in Python, from basic arithmetic operations to complex logical operations. There are different types of operators in Python. Let's learn each of them in detail. First, arithmetic operators. These operators are used to perform basic mathematical operations such as addition, subtraction, multiplication, division, modulus, exponentiation, and float division. Let's take a look at this example where we have performed all these operations on these two variables a and b. If you are confused about division and float division, modulus and exponentiation, let me explain. Division divides the first operand by the second and returns the quotient. In this example, as we can see, 20 is divided by 10 and we get the quotient 2, and it will be in the format of float. Coming to float division, it also does the same, but it returns the largest integer less than or equals to the result. For example, if we consider the result is 3.5, it will give the result 4 or 3, and the result should be in integer only. Coming up modulus, it returns only remainder of the division, that is 0 in this case. Finally, exponentiation. In this, we raise the first operand to the power of this second operand. Here 10 is raised to the power 2, that is 100. If we consider 5, it will give 25. Next, let us explore comparison operator. Comparison operator, we compare two values and return a Boolean result. The operators we use in this are equal to, not equal to, greater than, less than, greater than or equals to, less than or equals to. This is an example for this comparison operator. We have performed all the operations on this. Here also the A value is 10 and B value is 20. As we can see, A is equals to B. The result of this is false and A is not equals to B, that is true. And 10 is greater than 20, that is false. 10 is less than 20, that is true. A is greater than or equals to B, that is false. And A is less than or equals to B, that is true. Next up, we will cover logical operators. Logical operators are used to combine conditional statements. Logical operators are and, or, not, and returns true if both statements are true, or returns true if one of the statement is true. Not reverses the result. That is, if the result is true, then it makes the result false. Take a look at this execution. Here A is 10 and B is 20. 10 greater than 5 and 20 greater than 15. Here both statements are true, so the result is true. In the next, here the statement is false as the OR statement requires only one statement to be true, so it returns true, not inverses the result. 10 is equals to 20. This is obviously false, not reverses the result, so we get the result true. Next, we will explore bitwise operators. Bitwise operators are used to compare binary numbers. The operators which comes under bitwise operators are and, or, XOR, not, left shift and right shift. If we consider this example, a binary number that is 10 is 1010 and B 20 binary form is 10100. Here and set each bit to 1 if both bits are 1. As you can see, here no two bits are 1, so the result would be 0. R sets each bit to 1 if one of the two bits is 1. So the result would be 4 ones and single 0. And the binary result is 30. XOR sets each bit to 1 if only one of the two bits is 1. As you can see, there are no two ones coming together. So the result for this also 30. Not inverts the given operator. So it changes the bits from 1010 to 0101, which is a 2's complement representation. The result will be minus 11. Bitwise left shift the bit of the operand to the left by specified number of positions. Each shift to the left doubles the number, which means if we consider there are three zeros and a single one, if it is shift to left by 1, it will be doubled, means 2. If it is left shifted here to here, that will be 0100, means the value will be 4. Likewise, the value will be doubled if it goes on left shift. From here, if it shift left 1 again, the value will become 1000. That is, this bit value will be 8. It got doubled from 4 to 8. Here A is left shifted, means it will give the result 40. In the next, we used right shift bitwise operator which shift the value right by the specified number of positions, and each right shift will half the number, means if the value is 4, it is right shifted, means it will become 2. For the B, the value is 5. Next, we will cover assignment operator. Assignment operators are used to assign values to variables. The assignment operators are these. This is assign, add and assign, subtract and assign, multiply and assign. Assign operator assigns the right hand operand to the left. add and assign, adds the right hand operator to the left hand operator and assigns the result to the left hand operator. Here left hand operand is C, that is 30, which we got from the first step, and A is the right hand operator, that is value 10. When we add these in the right hand operand, C plus A, that is 30 plus 10, which gives 40. Likewise, we perform multiply and assign, which gives 80. As in the previous step, C is updated, so we get 40 into 2, 80. We also have other operators such as divide and assign, modulus and assign, exponential and assign, floor division and assign. You can search in Google and refer them. Next, we will cover identity operator. Identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. Means it should be the same object, not the similar object or identical object. Identity operators are is and is not. Is returns true if both variables point to the same object. Is not returns true if they don't point to the same object. Coming to this example, here in the execution, as you can see, x is z. As I have said, it should refer to the same object, not identical or similar object. As z is x, which has same memory location, then it returns true. In the next, as you can see, x is y. It returns false because their memory location is not same, but they are identical or similar. Next, x is not y is not returns true if they do not point to the same object as x. From the above explanation, we can tell these did not point to the same object, so we return true. Let's cover the last operator, that is the membership operator. Membership operators are used to check if a sequence is present in an object or not. Membership operators are in and not in. In returns true if the value is found in the sequence. Not in returns true if the value is not found in the sequence. Coming to the example, if we consider we have a list which contains only 1, 2 and 3 in the list. For the first statement, 1 in x, 1 is present in the list, so it gives true. Coming to the next statement, 5 not in x, not in will return true if the value is not found in the sequence. We have taken a sequence of list 1, 2, 3 which does not contain 5, so the result is true. Before concluding the video, let's have a quick overview of some of the most important data which we have covered in this video. In this video, we have covered all the data types and operators. If you found this video helpful, don't forget to like, share and subscribe for more Python content like this. See you in the next episode.